Okay, now let us talk a little bit about balancing chemical equations. This is the procedure that I want you to follow for balancing all chemical equations. The first thing that you should do is always balance all the other elements other than oxygen and hydrogen. The reason to do those other elements first is because oxygen and hydrogen oftentimes occur in even and odd numbers on either side of your reaction. So you want to be careful about doing those last. Work on complicated formulas first and consider elements last. Elements are things that occur as just one element in a compound. So oxygen, hydrogen, sodium, anything that has one element in the compound, you should consider that last because you can manipulate that however you want. Okay, here are some tips for balancing equations. I'll be talking about this a little bit more in depth as we're going through the examples. If you want to look in your book on page 137, there's a great reference there about tips and tricks for balancing chemical equations. And here is what we're going to be working with. A general chemical equation is something where you start out with reactants on the left side, and through a series or a chemical reaction, you're going to be yielding or producing products. Now, the thing about chemical reactions is that there's this thing called conservation of mass. It's a law that states that no matter can be created or destroyed. Therefore, on either side of your chemical equation, you have to have the same number of elements. Same number of elements on either side of your reaction. In other words, if I have 2 carbons on the left, I have to have 2 carbons on the right. So you have to have equal numbers of each element on both sides of your chemical equation. Okay, the best way to learn balancing chemical equations is just by doing examples. Okay, so in our first example, we have something that's a combination reaction. You're adding 2 things together to yield one product. Here you have hydrogen plus nitrogen yields ammonia gas. Okay, so what I want you to do is balance everything other than hydrogen first, so that would be the nitrogen. Now, this 2 means that there are 2 nitrogens here. So what I like to do is set up a little table, reactants, products. Here we have H and N. On the left we have 2 hydrogens and 2 nitrogens. And on the right we have 1 nitrogen and 3 hydrogens. This 3 only applies to the H. There is 1 nitrogen in ammonia. Okay, so firstly what we have to do is make these 2 numbers the same for nitrogen. How do we do that? Well, we're going to multiply ammonia by 2. So if we put a 2 out in front here, that'll change this number here from a 1 to a 2. This 2 is going to apply to both the N and the H. And now you're going, because this is what we call a coefficient, it means that we have to multiply every number here by this coefficient. So 2 times 3 is 6. Now, we have equal numbers for our nitrogen, but the hydrogens are not balanced. So how can we make this number the same as this number? We have to multiply H2 by 3. 3 times 2 is 6. So here we have 6 H's on the left and on the right, 2 N's on the left and on the right. This equation is balanced. Now, how do we write this properly? This is what your reaction would look like. 3H2 plus 1N2 yields 2NH3. Now, do you notice in front of the N2, there's no number 1 there. Even though the number 1 is implied, we do not ever write the number 1. So we're not ever going to write any of the 1s. Just the same as we don't write 1s here in compound formulas, we don't write them as the big numbers either. Now, these big numbers, I alluded to this earlier, these numbers are called stoichiometric, S-T-O-I-C-H-I-O-M-E-T-R-I-C, stoichiometric coefficients. A coefficient in chemistry is the same thing as it is in math. It's a number that is in front of a number that you multiply stuff by. So those numbers are called stoichiometric coefficients. And there's one in front of every compound in every chemical reaction. The ones you don't see are those implied ones. Okay, so that's a balanced equation. Now, let's balance this equation here. Remember, we're going to wait till the end to balance the O's and the H's. So let's do the most complicated formula here. Looks like Al2O3. Let's balance that first. I like to write my little chart here. That can sometimes give you help knowing what to start with. This is what we have on both sides of the periodic table. Right now our coppers are balanced, but our aluminum and oxygen are not. So let's take a look at balancing. Well, let's take a look at balancing the aluminum first. Sometimes, guys, the only way to figure out these problems is by doing a little bit of trial and error. Okay, so if we want to change this number to a 2, we would have to put a coefficient right here. Then these two elements are balanced, but that oxygen is not. So we have to do that next. We can put a 3 there. Now, you're going to have to change on this little table here every time, for every element that you're changing there with that coefficient. There's a copper in that molecule, or that compound there. So that means that we have 3 coppers on the left now, as well as 3 oxygens. So now we have the oxygens and the aluminums balanced, but not that pesky old carbon, or copper. So how are we going to balance that? Well, that's easy. All we have to do is put a 3 right here. And then we should be fully balanced. Okay, let's take a look at this last example here. In this equation we have potassium, oxygen, and hydrogen. We have 2, 2, and 2 on the left. Don't forget, you have to add all of each kind of element. There's 1 oxygen here, 1 oxygen here. 1 plus 1 is 2. And then we have 1 of each over here. How do you balance this? Balanced. Okay, now I want you to pause it and work numbers 4 and 5 for me, and then rejoin and I'll give you the answer. In this question, if you're getting stuck on this, you should make sure that you balance that carbon first. So you're going to have to start by putting that 3 there. And then in this problem, you need those 2 2's to balance this equation. Now, number 6 here is a chemical equation that is written out in words. If you can transform these words into chemical symbols, so if you see water, that's H2O, write me a compound, a balanced chemical equation with the compounds written out in their formulas. And if it's balanced, I will give you, I'll give you 5 extra credit points towards homework number 3 if you can get this to me by Friday noon in an email. And please, please, please be sending to my Gmail because I'm not getting the stuff you're sending me on Jewel. So send that to my Gmail, please, and if you can do that to me by Friday at noon, I'll give you 5 extra credit points. That's a lot. Okay. Let's take a look at we'll do that in a movie.